Good day to all of you. My name is RJR Maligaya and I'm here with Joyce Prey Bargadas, Altea Miliar, Niralina Hilon, Vince Adrian Puentes, Ralph Andre Caballero, and John Louis Palma. And we are the Group 3 presenting scaling algorithm, basic space motion including rigid body dynamics, physical particle system, and mass spring networks for cloth, flesh, and hair. To start, I will be presenting scaling algorithm. Objective. At the end of this topic, you will be able to define what is scaling, understand what is smooth scaling algorithm, differentiate linear blend scaling, LBS, and dual quaternion scaling.
First, we have to define what is scaling.
What is scaling algorithm? Scaling algorithm is the process of attaching a renderable skin to an underlying articulated skeleton. Once the armature, the character skeleton, is ready, it is necessary to parent the character or skin to it. Skinning is a technique for creating smooth mesh deformation with an armature. Essentially, the skinning is the relationship between the vertices in a mesh and the bones of an armature, and how the transformation of each bone will affect the position of the mesh vertices.
Scaling is the process by which the bones is attached to the surface vertices, so that when the bones is animated, the vertices will transform accordingly as a skin being deformed.
Dahil nagawa na natin tong skinning, we already have the general idea about it. But the algorithm behind the skinning is di pa natin alam. So, I'm here to explain the first algorithm, which is smooth skinning algorithm. But before we define smooth skinning algorithm, we need to consider the two very simple approaches of skinning, which is rendering character as rigid components and simple skinning. First approach is rendering characters as rigid components. Robots and simple characters made up from a collection of rigid components can be rendered through classical hierarchical rendering approaches. So, when we say rigid, meaning unable to bend or dinadeform, katulad ng animation na ginawa natin sa Prisma 3D. And here is the example of it.
Credits to John Louis Palma for his outstanding animation. As you may notice in his animation, he uses rigid components. There is no deformation happening on the vertices. And that is one of the basic approaches of scaling, which is rendering as rigid components. And this is its illustration.
And the second approach is simple skinning. With a simple skinning approach, the character's skins is modeled as a single continuous mesh. Every vertex in a mesh is attached to exactly one joint in the skeleton, and when the skeleton is posed, the vertices are transformed by their joints' world space matrix.
And here is its illustration. So dito sa simple scaling, the character is modeled as a single continuous mesh. Tapos, every vertices, mape-parent mo lang siya sa isang bone. Unlike other method, di ba? Pwedeng yung dalawang bone mag-share sa vertices. Makikita nyo tong concept na to mamaya sa linear blending. Para lalo pa nating maintindihan yung dalawang basic scaling approaches, let's compare them. Kung makikita nyo sa rendering character as rigid components, hindi talaga siya deform kasi nga rigid. Dito naman sa simple scaling, same thing pa rin naman, hindi pa rin naman nade-deform yung bawat objects. Pero, yung vertices na nakaparent sa bones, nagkakaroon na siya ng deformation dito sa part na to. So, we define the basic skinning approaches. Now, we can understand what is smooth skinning.
Smooth skins extends the concept used in a simple skin. With smooth skinning, each vertex in the mesh can be attached to more than one joint. Each attachment affecting the vertex with a different strength of weight. The final transformed vertex position is a weighted average of the initial position, transformed by each of the attached joints.
To visualize smooth skinning algorithm, let's compare them all. Itong smooth skinning algorithm, extension lang siya nitong simple skinning. Kumbaga, upgrade lang. Kung mapapansin nyo, sa smooth skinning algorithm, the vertex can be attached to more than one joint. Kaya, kapag iminob natin yung bone, nai-impluensyahan yung ibang vertices. Unlike dito sa simple skinning, you can attach the vertex to exactly one joint, kaya limited yung kanyang deformation. So, there are two skinning techniques used in Blender, which is linear blending skinning algorithm and dual quaternion skinning algorithm.
Linear blend skinning, or LBS. Linear blend skinning is probably the most common algorithm used to deform a mesh using skeletal structures. It is used in game engines such as Unreal and Unity. The main advantage of linear blend skinning is the fact that it is not computationally intensive, and it still provides acceptable deformation in a good range of situations. It also supports all basic transformation, which means that the mesh geometry can be not only rotated but also translated and scaled. That's not to say that LBS doesn't have any drawbacks. The main issue is loss of volume in bent areas and so-called candy wrapper effect that happens when skeleton joints are twisted. Dual quaternion skinning is an advanced rigging technique that binds a mesh to skeletal joints. Unlike the popular alternative, linear blend skinning or LBS, DQS avoids the undesirable candy wrapper effect and effectively simulates volume preservation. DQS is a powerful technique, but to get desirable result, it must be extended to meet the needs of production environments, and is therefore not a simple drop-in replacement for LBS.
Dito naman sa dual quaternion skinning, sinosolve niya lang yung problem sa linear blending, which is preserving the details. Dito sa Blender, there is an option called Preserve Details, which uses dual quaternion algorithm. It is off by default. If this option is off in Blender, it uses linear blending algorithm, which doesn't preserve detail when the bone is moving. And that's all for skinning algorithm.
Physics-based motion. In physics, motion is the phenomenon in which an object changes its position over time. The motion of a body observed by attaching a frame of reference to an observer and measuring the change in position of the body relative to that frame with change in time.
So para po mas maganda po yung result ng animation, minsan po nag-a-attach po ng reference yung mga animator dun sa tao para ma-measure po yung position ng nung object frame by frame para po mas accurate yung result.
What is physics-based animation? It is an animation that is driven by force. Based on the force, acceleration or deceleration can be calculated, which can then be used to calculate and update the velocities and values of the animation at each frame. The animation comes to rest when the force reaches equilibrium.
Katulad po nung nabanggit kanina, force daw po yung pinaka nag-ooperate or kumokontrol sa isang object sa physics-based motion. At kapag po yung object ay nag-reach po ng equilibrium or kapag balance lang siya, hindi po siya kikilos ng walang force na tumutulak dito.
Physics-based motion in animation. The term physics-based modeling or physically based modeling has become a techniques that all share the approach of defining a physical principles of behavior of their models. In computer graphics, common elements are classical dynamics, motion based on forces, mass inertia, with rigid or flexible bodies, interbody interaction, and constraint-based control.
So ito po yung mga example nung tatlong element na nabanggit po kanina ng physics-based motion sa computer graphics, which are classical dynamics with or flexible bodies, interbody interaction, and constraint-based control.
How is it different? Natural. Animation looks more natural and mimic real-time movements. Reactive. When the target value changes, animation keeps momentum or velocity and with a smoother motion. Less visual disruption. Animations appear smoother and more responsive, and you see less disruption in animation.
Good afternoon. I am Nirelin Ahilon reporting the rigid body dynamics. Rigid body dynamics. In the physical science of dynamics, rigid body dynamics studies the movement of the systems of interconnected bodies under the action of external forces. The assumptions that the bodies are rigid simplifies analysis by reducing the parameters that describes the configuration of the system to the translation and rotation of the reference frames attached to each body. This excludes bodies that display fluid, highly elastic, and plastic behavior. Dito sa part na to, it is about the movements ng mga bagay sa isa't isa kahit mayroon man o walang external forces. Ibig sabihin kasi ng rigid is unable to bend or change the shape. But under rigid body dynamics, yung bagay na rigid or unable to change its shape is nababago under different circumstances. Why use simulated physics? Humans are also good at spotting physical irregularities. It saves artists time and focus on the character, story, and aesthetics. It also directly captures the real motion via video camera or motion capture that can be limiting. Simulation is often cheaper, safer, and makes otherwise impossible animations feasible. Kasi ang mga tao, madali silang makapansin ng mali. Madali silang makapansin kung weird yung itsura nung animation mo. Ngayon, kaya gumagamit ng simulation para makita kung maganda ba yung kalalabasan ng final product mo. Saka, maganda din ito to make the animated thing realistic, to give focus on the character, the story, and the aesthetic. Also, simulation is cheaper and safer. Some physics that is included in an animation. Newton's second law. Rather than prescribed velocities, we often want to use physics, classical mechanics, to solve for both the x and v, given a set of applied forces, F. First, assign each particle, I, some fixed mass, mi. Then, recall Newton's second law. Force is equal to mass multiplied by acceleration. Ngayon, some physics that is also included in an animation, second is yung force. What physical forces might be used to drive a particle system. Ngayon, ang under ng force is yung gravity. Earth-specific gravity treated as a constant. F is equal to random numbers. Ngayon, ang gravity, alam naman natin na siya yung nagpupull sa atin closer sa Earth. Ngayon. So, tapos ito namang wind, simple lang to. Ito lang yung pag pinakita siya sa animation, yun lang yung pagsunod ng mga bagay sa hangin. Tapos, springs and elasticity, a simple way to model complex structures, hair, cloth, jelly, is joining the particles with spring forces. Mamaya magpapakita ko ng examples na itong mga to para mas madali siya maintindihan. Pero dito sa elasticity, katulad lang din siya nung sa damit at sa jelly, yung pagiging malambot nila, yung pagpapakita ng texture na ganon. Tapos, fourth is friction, force resisting the relative motion of solid surfaces, fluid layers, and material elements sliding against each other. Ito naman yung pagkikiskisa ng dalawang bagay. Collision and contact, one strategy for modeling collision is penalty repulsion forces, essentially temporary springs that opposes interpenetration of objects. Ito yung pagbabanggaan naman ng mga models or mga bagay. Ngayon, damping and viscosity is often helpful to gradually slow down the motion so it doesn't oscillate forever. A typical damping drag forces opposes the motion of the particles and is proportional to the velocity. Too much damping can yield unrealistic behavior. Ngayon, ang example na maganda ng viscosity is yung lava. Kasi ang lava, hindi naman siya katulad ng viscosity ng water na mabilis dumaloy. Ang lava is medyo slimy siya, kaya mabagal siya. Pag pinakita natin yon, makikita na magkaiba yung viscosity ng fluid na to dito sa fluid na to. Ayan, yan. Ngayon, ito yung unang example yung sa gravity. Yung pagpupul ng Earth's gravity punta sa kanya ng isang bagay. Kaya nga tayo nag-i-stay sa Earth gawa ng gravity. Tapos ito yung wind naman, makikita na sumasabay yung mga grass at yung mga halaman dun sa hangin. Sa elasticity naman, makikita naman dito yung yung parang pagiging jelly-like nung model. Cute. Tapos, dito naman sa friction, yung friction between the poles of the bear and yun yung nilalakadan niya, yung ladder. Tapos, dito naman siya collision and contact. Ito naman ay space collision. Makikita na una, nag-ikot-ikot muna sila sa isa't isa, tapos nagbanggaan sila. Yun, parang Big Bang Theory lang yun. Tapos, ito namang viscosity damping, ay makikita natin na yung ibinubuhos dun sa may skull is hindi ganun katulad ng sa regular na tubig. Parang medyo malapot siya. Makikita dyan yung pagkakaiba ng viscosity niya dun sa regular na tubig. Yan. Sample way to do rigid body dynamics in animation. Number 1 is build your asset. The first step of making this work is to build all your assets. Most people start by making a simple ball bounce on the floor, but to help you understand, we will take things a step further. Use simple geometry to set up seesaw, using an extruded pyramid with a plank lying across it. Then add the cube to one end. Lastly, position these pieces so that the cube end is resting on the floor or near it. Now add the sphere to the scene and position it above the opposite end to the cube. We should have something similar to the image. Yan yung image. Ngayon, gumawa lang ng simpleng bagay. Doon lang tayo sa simpleng bagay mag-i-start. Kaya, yan lang yung natin. Parang simpleng siso lang. The second is yung add tags. Now, select your ball into the object manager and right-click it. Ngayon, dapat dito maging familiarize ka na sa gagamitin mong application ng pag-animate. Katulad ko na ng Blender, dapat familiarize ka na doon para dito sa pag-add tags, ikaw na lang yung mag-iiba-iba nung gusto mo na pwedeng maka-apekto dun sa animation mo. Ikaw na yung bahalang mag-adjust. Yan. Ngayon dito, katulad lang din siya nung sa second, adjust the settings naman. Adjust the settings based on your preferences naman. Yan. Kita naman dun. Magkakaiba-iba kasi yan sa gagamitin yung application. Tapos sa pang-apat is change the density. What needs to be fixed at this point is matching the dynamics of the materials you will be applying. Changing the density meaning applying the rigid body dynamics into your animation to make it real or lifelike. Pangalawa siya sa huli kasi dito makikita mo na kung ano yung magiging kalalabasan ng output mo pag inad mo na yung mga rigid body dynamics na naituro sa inyo. Ngayon, add the connector. The final fix is to ensure that the plank stays put but is able to rotate. Make sure that all the model is connected to each other to simulate properly. Ngayon, pag ipinilay mo na siya, pag tinignan mo na yung animation niya, makikita mo na maayos siya. Ngayon, ito yung link dun sa final output na nakita ko. Yun lang. That's all. Thank you.
Hi, my name is John Louis A. Palma and I will be discussing about physically based modeling with particle systems. What is particles? A particle refers to a quantity of matters that is used by scientists to construct theories about their field of study. Typically, it is any object that has mass, position, and velocity and responds to forces, but that have no spatial extent. We all know that we are all familiar to this term, particle. Particle is a very small amount of something. For example, imagine picking up a rock and smashing it with a hammer so that it breaks up into smaller fragments, then successively breaks each of the fragments into even smaller fragments until the resulting pieces are so small that they cannot be further broken down. These non-breakable fragments are of the example of particles. What are particle systems? Graphical technique that simulates complex physically based effects. Particle systems are collections of small images that when viewed together form a more complex fuzzy object such as fire, smoke, weather, or fireworks. These complex effects are controlled by specifying the behavior of individual particles using properties such as initial position, velocity, and lifespan. So yung particle system, it refers to a computer graphic technique to simulate a certain fuzzy phenomena. And when we say fuzzy, ito yung malabo, which are otherwise very hard to reproduce with conventional rendering techniques para makapag-produce ng mga realistic game physics. And the examples of such phenomena which are commonly done with particle system includes fire, explosions, smokes, flowing water, sparks, falling leaves, clouds, fog, snow, dust, meteor tails, or abstract visual effects like glowy trails, and etc. Particle system as technique in animation. Particles are lots of items emitted from mesh objects, typically in the thousands. Each particles can be a point of light or a mesh, and be joined or dynamic. They may react to many different influences and forces, and have the notion of a lifespan. Dynamic particles can represent fire, smoke, mist, and other things such as dust or magic spells. A small, simple image or mesh that is emitted by particle system. A particle system can display and move particles in great numbers to represent a fluid or amorphous entity. The effect of all particles together creates the impression of the complete entity, such as smoke. They are small, simple images or meshes that are displayed and moved in great numbers by a particle system. Bali yun nga, each particle represent a small portion of a fluid o yung tinatawag nating amorphous entity o yung mga bagay na walang tiyak na hugis. And the effects of all particles together, pag nagsama-sama sila, it creates the complete entity or yung buong impression ng isang bagay, kagaya ng usok. For example, using a smoke cloud, each particle would have a small smoke texture resembling a tiny cloud in its own right. When many of these mini clouds are arranged together in an area of the scene, the overall effect is of a larger volume filling clouds. So yun nga, 'di ba yung clouds di ba mga smoke siya. Yung particle papasok siya dun sa mga maliliit na parts ng smoke. Tapos kapag ka nakabuo ka ng maliliit na ulap at nagsama-sama sila dun sa isang part or sa isang portion ng sky, ang resulta nun ay mas malaking volume ng ulap o mas makapal. Kasi parang pinagsama-sama lang siya na maliliit na group of particles ng cloud. Dynamics of the particle system. Each particle has a predetermined lifetime, typically of a few seconds, during which it can undergo various changes. It begins its life when it is generated or emitted by its particle system. The system emits particles at random position within a region of space shaped like a sphere, hemisphere, cone, box, or any arbitrary mesh. The particle is displayed until its time is up, at which point it is removed from the system. The system emission rates indicates roughly how many particles are emitted per seconds, although the exact times of emission are randomized slightly. The choice of emission rate and average particle lifetime determine the number of particles in the stable state. Example, where emission and particle death are happening at the same rate, and how long the system takes to reach the state. So, bali dito, ni-explain lang na yung mga particles has a predetermined lifetime or may specific lifespan. System emission rates indicates how many particles are emitted per seconds by a particle system. Dynamics of particles. The emission and lifetime settings affect the overall behavior of the system, but the individual particle can also change over time. Each one has a velocity vector that determines the direction and distance the particle moves within each frame update. The velocity can change by forces and gravity applied by the system itself, or when the particles are blown around by a wind zone on a terrain. The color, size, and rotation of each particle can also change over its lifetime, or in proportion to its current speed of movement. The color includes an alpha transparency component, so a particle can be made to fade gradually in and out of existence rather than simply appearing and disappearing abruptly. Here, ipinaliliwanag lamang yung mga properties and things that could affect the particle, like its velocity that determines the distance and direction of movement of the particle. At yung mga bagay na maaaring makaapekto sa behavior ng particle na ina-apply ng system like forces and gravity, and by that, one example is yung wind or hangin. Binabanggit din dito yung properties like colors, size, rotation na maaaring magpabago-bago due to the factor that affects the particle. The process for working with standard particles in Blender. 1. Create the mesh which will emit the particle. And the mga example ng object or meshes na to ay mga nabanggit kanina, like fire, flowing water, dust, and more. Number 2, create one or more particle system to emit from the mesh. Many times, multiple particle systems interact or merge with each other to achieve the overall desired effects. So yun nga, pwede mag-merge or mag-combine yung isa o higit pang particle system para lang ma-achieve o mabuo yung desired effect na gusto mong gawin. Number 3, tailor each particle system settings to achieve the desired effect. So yun nga, parang mag-a-adjust ka lang or aayusin mo pa yung particle system nung mesh para lang mabuo o magawa yung output na gusto mo o yung desired effect. Number 4, animate the base mesh and other particle meshes involved in the scene. So yun nga, parang hindi lang yung mesh na yun ang aayusin mo, kundi yung mga involving other things na nasa paligid niya para mag-combine or mag-sync silang lahat. Number 5, define and shape the path and flow of the particles. Number 6, make final render and do physics simulations and tweak as needed. So, yun sabi dito sa number 6, parang pagka nag-final render ka, if it is necessary for you to make adjustment, do it daw. Parang ganun. Parang huwag ka makontento lang. Parang adjust lang ng adjust para mas gumanda.
So, good day. Since na-discuss na ni Louie yung about sa particle system, so ako naman, ang gagawin ko is magde-demo ako on how to implement particle system sa Blender. So, gagawa lang dun tayo ng basic particle system. So, alisin muna natin tong camera. Yan, delete natin siya. So, ito, gagamitin natin yung cube. Tapos, magdagdag tayo ng plane and sphere. So, itong plane, ito yung magiging, natin, particle system mismo. Then, itong sphere, ito yung ating magiging particle object. So, scale muna natin tong ating cube. Oops. Yan. Bali, ang magiging itsura niya is parang magiging container siya. So, edit mode. Lagyan natin ng loop cut. Wait lang. Pinitin natin yung face. Okay na ba? Tapos extrude natin. Yan, para tingnan muna natin sa wireframe kung okay ba. Parang mas mukhang maging container talaga siya. So, ito, scale ulit natin siya. Oops. Baby. Taas natin. So, yung plane, scale natin siya na kasing laki nung mismong container natin. Hindi naman, parang aanuhin lang natin. I-akumala na natin sa size ng mismong container. So, yun, okay na to. Then, move natin pataas. Then, after that, yan, i-add na natin sa mismong plane yung particle system. So, hanapin dito yung ano ba to? Particle properties. Then, click natin tong add button. So, as you can see, may mga terms dito. Yung number, seed, frame start, and lifetime random. So, itong number, ito yung yung maximum amount of parent particles na gagamitin natin sa simulation. So, let's say, lagyan natin ng 100. Then, itong seed, ito naman yung starting point to produce random numbers sa simulation na gagawin. So, set a 0 na lang. Then, frame start, ito yung start frame ng particle emission. So, pwedeng magkaroon ng negative values which enables you to start the simulation before the actual rendering. So, ito, gagawin na lang din nating 1. Then, itong end naman, ito yung start, ito yung end frame na mismong particle emission. So, set natin as 150 din. 150. Then, lifetime, ito naman yung lifespan ng mismong particle. So, huwag tayong malito dun ha. Yung sa lifetime, ito yung mismong particles sa lifespan ng particles. Then, itong end, ito yung mismong ending point ng mismong simulation or ng mismong animation. So, ginawa ko na lang siyang 150 parehas. Then, itong lifetime random, ito yung random variation ng lifetime ng given particle. So, set as 0. Tingnan natin. So, hindi pala siya ganun kaganda pag 100 lang yung number. So, set natin siya as 1,000. So, may iba pang terms dito, which is yung ito, sa emit from. Meron ditong pagpipiliin tatlo, vertices, faces, volume. So, pag tinindot natin yung vertices, yun, yung nai-emit niya yung particles sa vertices ng mismong mesh. So, as you can see, dun sa apat na corner ng ating plane. Then, kapag naman dito sa faces, so, yung emission ng particles ay nagagaling sa surface or sa face ng mismong mesh natin, which is the plane. Then, sa volume, so, parang parehas lang siya ng faces. Hindi ko makita yung variation nila. Pero, try natin na gamitin yung volume. So, yun. So, dito, ano bang nitong sphere na to? So, ito yung magiging natin, particle object. Ayun yung mismong lalaglag dun sa ating particle system. So, paano gawin yun? Ayun, pindutin natin yung render tab. Then, render as object. Tapos, pindutin natin tong sphere. Yan. So, as you can see, yung nalalaglag na particles is sphere na yun. So, palikayin natin yung mismong object, particles. Gawin natin 120. Yan. So, as you can see, yung nagpapasto doon sa mismong container yung ating mga particles. So, paano gawin na hindi siya magpapastro dun sa ating container? So, punta tayo dito pindutin muna pala natin tong cube. Then, punta tayo sa Ano ba 'to? Collision, then pindutin natin 'tong friction, 'yan, wait. So, as you can see, hindi na nagpa-pass through yung mismong particles dun sa ating container. So, in place na lang siya. So, siyempre ang ano lang ang ating goal naman dito is i-flow yung mismong particles. So, ang gagawin natin is increase din natin, wait, mali pala. Balik ulit pala tayo dito. Ating particle system. Advanced. Ito, pilitin natin yung physics type, which is the fluid. Yan, parang yung maging flow ng particles natin is yung parang pag nag-aano tayo ng tubig. Yan. Dagdagan natin viscosity. Natin itong advance. Lakihan pala natin yung ano, yung mismong size ng particles. Oops. Asan na yung render? Lakihan natin. Yan. So, di ba nag-overflow na siya? So, ayun yung basic ano lang siya, particle system na implementation. So, yun, ito na yun. Nag-overflow na siya. Mas maganda pala pag medyo malaki para nakikita na yung pag-ano nung mismong particle sa container. So, ayun yung sample ng pag-implement ng particle system. Try nating liitan. Yan. Yan, para mas maganda siyang tingnan. So, doon nag-e-end yung ating basic tutorial ng pag-implement ng particle system.
So, good day po. Ako po si Vince Adrian and Fuentes, and here to report about the mass spring network for cloth and flesh and hair. So, first define spring or yung force na ano natin siya. It's a simple way to model complex structure like hair, cloth, and jello in which we join particles with spring forces. This is also known as the mass spring system. Ngayon, pag gumagawa tayo o nagsisimulate tayo ng ganito, kailangan natin ng particles which is i-connect natin. Commonly, 2 lang. Pag sa yung simple, then we have the given rest or the length or L and has the given constraint or stiffness which is letter K. So, bali yung stiffness or K is yun yung parang pinaka nagde-define kung gaano ka-resistant yung siya pag ina-apply natin siya ng force. Like, gaano siya yung value niya pag binabanat or hinihila sa per end. Now, ito naman yung figure natin para mas madali natin maintindihan. Which, meron tayong fixed static wall at saka yung M, which is the represent of dulo ng bawat particle. And we have the length or L. Ngayon, pag hinila mo siya, magkakaroon siya ng application ng force, displacement, at saka yung incrementation of X. So, meron tayong tinatawag na Hooke laws for linear spring, in which the restoring force is linear proportionally to the amount of displacement from the rest of length. And it acts in the opposite direction of the displacement, where K is a proportional constant that controls the spring stiffness. So, yan. Yung formula natin is F equals negative K multiplied to the incrementation of X, which is F is yung ating force, then yung ating K or stiffness na minumultiply natin sa negative K or yung ating negative nano and the incrementation of X. Dito, malalaman natin yung ano ba yung value ng displacement. Ganon. Ngayon, note na ngayon, if yung material is stiff or mataas ng value ng stiff, ang nangyayari niyan is mas maliit yung time step. At pag yung paglaki ng K or yung value ng K niya, yung pinaka-limit niya para sa stretchiness is mas tawag yun. The spring value pag is parang mas mabilis siya stretch, mababanat or hindi kakayanin, mas kailangan niya bumalik dun sa ating rest length. Ganun. So, pagdating naman sa 3D, syempre, kanina yung ating inanis lang is 2D or 2D. Pagdating sa 3D, magkakaroon tayo ng mababago yung ating formula. So, for spring joining two particles with position vectors x sub 1 and x sub 2. Which is yung nasa formula, pinipicture dun sa formula na nasa PowerPoint. And forces in the direction of spring and proportional forces in the direction of the spring and proportional to the difference with rest length L. So, pag 3D namin pinag-usapan natin, papasok na dyan yung ating factor na dagdag, which is yung direction. And to find the direction, meron tayo na yung kailangan natin siyang i-compute, which is the difference of x sub 1 and x sub 2 over the absolute value of x sub 1 and x sub 2. Nasa formula naman siya para mas madaling makita. Then, after that, mababago din yung ating formula to calculate the displacement, which is now the absolute value of difference of x sub 1 and x sub 2. Then, isusubtract pa siya sa value ng L or yung ating length. Then, yun. Yung ating pag-calculate ng force. Yun nga, kagaya ng natin kanina is yung negative K or negative constraints multiply to the displacement, then multiply to the direction. So, in quick recap, paano natin yung application ng spring? Spring links the particles, then dun papasok yung pag-link niya, dun papasok yung mga force na tinaka natin kanina. Then, spring also try to keep the rest length and preserve the length of the spring. The issues or the problems here are the strength or actual length will be greater than rest length and numerical oscillation. Yung numerical oscillation is yung minsan kasi, di ba, pag nagba-back and forth yung spring, which is kailangan na din natin i-consider. Ngayon, paano ba siya ini-apply sa hair? So, bale, yun, stimulating hair. Like string, it add deformation forces proportional to the angle between segments. So, yun nga, parang nagdadagdag tayo ng each particle between the hair root and the hair tip. Depende sa kanto, is dito na determine natin kung yung buhok ba natin is straight or gano'n ka-curly yung ating buhok. Then, a single chain of masses and spring can model a strand of hair. And yun, pag na-model na natin nadagdag na natin yung mga points, yun na yung pwede na siyang gamitin to simulate the hair. And alternate spring. This discourage the hair from collapsing when you bend it. So, bale, aside from pagka-determine natin kung hair, kung straight or yung curly yung buhok, nakakatulong din yung pag-a-add ng particles between the endpoints para hindi mag-collapse yung ating model. Ngayon naman, application for model of cloth. Dito, iba na yung yung spring force natin is ni-apply siya in a grid of particles. Similar kung paano ba nato yung nagmo-model ng plot. Then, dito, yung spring force na yon ang nagde-determine kung paano ba siya kung stretching o sharing at saka yung paano siya sa bending. Parang yung spring force yung nagde-determine kung ganong value sa pag nagkakaroon tayo ng displacement or stretching, ganon. So, ano ba yung mga issues or problem sa ating paggamit ng mass spring system? So, una sa lahat, we cannot control the stretching and bending strength independently. Kasi, the bending springs also affect the stretching as material in a clear way. So, hindi natin siya makakontrol kasi depende pa rin yung pagkakaano niya sa material na ginagamit natin. Kasi iba yung material for cloth. Kahit sa cloth, iba-iba pa din yung materials na kailangan i-simulate. Kaya ng leather, cotton, mga ganong bagay. And if we double the massive resolution, will the behavior remain the same? Ideally, magre-refine lang yung mesh. And in general, hindi siya yung spring, yung behavior ng spring is hindi siya maapektuhan. Kasi hindi siya maapektuhan. And sa ngayon kasi, nagiging available na yung ibang finite element, So, nagkakaroon na tayo ng accurate na finite element and final approach na ino-offer sa pag-visual effect. And medyo hindi naman siya or nagiging parang limited na yung paggamit ng mass spring system. But as of today, meron pa rin namang mga teams na gumagamit ng mass spring models. Yun lang. Thank you.